This is MeshCast, where we separate verified evidence from hype. Today, quantum computing. If you believe the headlines, a Google chip solved a problem in 5 minutes that would take a supercomputer 10 septillion years, longer than the age of the universe. And the head of Google's quantum lab even suggested it might prove we live in a multiverse. That sounds incredible, and some of it is real, but a lot of it is hype. So today, we're going to separate the actual science from the marketing. Is quantum computing really about to change the world, or is it still a long way off? The honest answer is more interesting than either extreme. Let's dig in. Let's start with what's real. In December 2024, Google announced a quantum chip called Willow. It's a 105-qubit superconducting processor. And it did two things. First, it completed a benchmark called random circuit sampling in about 5 minutes, which Google claimed would take the world's fastest supercomputer 10 septillion years. That's the headline that went around the world. But here's the catch. That benchmark has no practical use. It's a constructed test, designed purely to show that a quantum computer can do something a classical one can't easily match. It's not solving a useful problem. So the 10 septillion year number, impressive as it sounds, is not evidence that quantum computers are ready to be useful. But Willow did something else that researchers actually consider the real breakthrough. It demonstrated something called below-threshold quantum error correction. Here's why that matters. Quantum computers are incredibly noisy. The more qubits you add, the more errors you usually get. But Google showed that if you scale up their error-correcting code, the error rate actually goes down by half each time you make the code bigger. That's the opposite of what had always happened before. It means quantum error correction actually works, which is something scientists had been chasing for 30 years. That result was published in Nature, and it's genuinely significant. It's the first time the theoretical path to a real, useful quantum computer was demonstrated in actual hardware. Now, the hype. The head of Google's quantum lab, Hartmut Neven, went further. He suggested that Willow's performance was evidence that quantum computers operate across parallel universes, the multiverse. That got huge headlines. But this is not established science. It's one interpretation, called the many worlds interpretation. Other physicists point out that the same results can be explained perfectly well without a multiverse. So no, Willow did not prove we live in a multiverse. That's an opinion, not a verified fact. And it's exactly the kind of thing that turns real progress into hype. Here's the honest, impressive part. Since Willow, the field has genuinely advanced. Multiple labs, including Infleqtion, QuEra with Harvard, Atom Computing, Microsoft with Quantinuum, and even China's Zuchongzhi chip, have now demonstrated logical qubits that outperform the physical qubits underneath them. That's the same error correction breakthrough, confirmed across different technologies. It's not a fluke, and it's not just Google. In October 2025, Google also reported a verifiable quantum advantage result, a 13,000 times speedup published in Nature. So the engineering progress is real, and it's accelerating. But here's the reality check. No quantum computer has yet solved a practically useful problem faster than a classical computer. Every advantage so far has been on narrow, contrived benchmarks, not real-world applications. And Willow's error rates, impressive as they are still far above what's needed for meaningful, large-scale algorithms. The field doesn't even have a killer app yet. With AI, the algorithms were ready and the hardware caught up. With quantum, the hardware is racing ahead, but the software, the algorithms, and the use cases are lagging behind. So the honest framing is that quantum is a half-built bridge. So when will it actually matter? The realistic range is this. Optimists say practical business uses by around 2030. IBM is targeting about 200 logical qubits by 2029 and 1,000 or more in the early 2030s. Skeptics, including some very smart people, say it's more like a decade or more out. Microsoft's research even found that quantum computers will only really shine on specific problems with exponential speed-ups, and a lot of the promised applications may never be practical. The most likely first wins will be in quantum chemistry and materials simulation, where quantum is naturally good. Breaking encryption is the furthest away because it needs millions of qubits. So here's my verdict. Quantum computing is real, and it's genuinely advancing. The error correction breakthroughs of the last couple of years are peer-reviewed, replicable, and a real step toward useful machines. That's the honest, impressive part, but it is not about to change the world. The headline numbers, the 10 septillion years, the multiverse, those are hype. No practically useful quantum computer exists yet, and realistic timelines put real utility around 2030, with full fault tolerance in the 2029 to 2035 range. The fair summary is this. Quantum is overhyped in the short term, but potentially underhyped in the long term. It's a half-built bridge. The engineering is racing ahead, but the algorithms and applications haven't caught up yet. That's the episode. Quantum computing is real. The error correction is a genuine breakthrough, but the world-changing quantum computer is still years away. So be excited about the science and skeptical of the hype. If this breakdown helped, subscribe, and we'll see you on the next MeshCast. Stay sharp.